So here's our class. I added this today. If you go into orientation module, at the bottom is information and video on the COS Giant Marketplace. College of Sequoias, they've had it open, I want to say for at least a year. They've had a pantry before that, but you used to have to walk to the center of campus to do it. And like walk off campus carrying like groceries and shit. A lot of people don't like looking like they need help with financial things. This is just a reality. No one likes to look broke at the cash register by like putting more in your cart than you got money for. No one likes to look like they need a helping hand. But in all reality, everybody has a helping hand at some point, whether or not it's financial or not. Oftentimes it is financial, and usually you ask your friend or your family for a fucking loan, but you still need help. Was driving by the place and I saw that it was open. And I walked in and I said, hey, I'm a teacher over here. Do you mind if I record what this looks like in here so I can show my students? And they said, sure, we're fucking excited. One day, I don't think they get a lot of people asking. They gave me a fucking stack of flyers if you're interested in it later on. So I recorded video, a little like it's like a minute and a half with my phone. I'm walking around, it's fucking shaky cam. I'm not a professional photographer, but you can see what they're offering in there. There's food, hygiene projects and shit like that. If you're struggling to make ends meet, take advantage of it. Okay? If you're 18 and still living with your parents, it's probably not a problem. But it might be for your parents, you never know. It's just like, why are you throwing fucking shade? Here's a link to the website so you can learn more information about it. And I also have a flyer up here. If you're interested in a flyer, you can come grab one after class. There ain't nothing wrong with getting help when you need it. Okay? And that is in orientations on your homepage. Just scroll down and you can take a look at it there. They got like cereals, soups. They got a frozen microwave shit section. There was I even saw some fresh veggies in there. The fruit I saw was like lemons, but I think they added other seasons of their fucking fruit. There was pastas in there, beans, like lots of things that you can have on like canned veggies and shit like that. Toothbrushes, toothpaste, shit like that. I liked it.
There's a video.
There's a video.
Show the video.
We got shit to do.
Right.
You wanted, all right, it's not that long. Since you really wanted it. Okay, this is the Giant Marketplace. COS offers free food and stuff for students. You got soups, cereals. You got pasta mix, you got some raviolis. Some macaroni and cheese. Trying to make sure I don't film any students. They don't want to be seen. You got all sorts of frozen stuff. Microwave pizzas. Got your waffles, your burritos, stuff like that. Some milk. Fresh veggies. Some fruits. Let's see, we got some more stuff over here. Some canned veggies and stuff. More cereals. We all know students love cereals. Who doesn't love cereal? We got a soup section. Stuff like hygiene stuff. Some beans. Some canned tuna and stuff like that. This stuff goes really a long ways when you're struggling on money. Don't forget that COS has got this stuff for you guys. Okay? Okay, this is the Giant Marketplace. See, Jesus, I sound all fucking breathy. I was not out of breath, but I sure sounded like it. Fuck. That was a terrible video. Either way, you can kind of see the stuff. It's literally holding the camera down because there's like 6 or 7 students in there. And nobody wants to be on film without being asked. Especially if you're taking a handout, basically. People get bothers people. I didn't want to do that, but I want to show everybody. Let's redirect to. All right. So we wanted to wrap up some last thing in math or chapter 5. But I can't even write the word map.
That's a good start.
We're off to a great start. Fucking video where the teacher's all being breathy in your ear. Can't spell his own subject, which is 4 fucking letters. Not 20, okay, we're gonna do 5.5B. Remember 5.5B or 5.5 was on counting techniques. And in there, we had factorials, we had NCR. And we had NPR. Our permutations or combinations and our factorials. But in all of these things, NCR and NPR. Our combinations where order doesn't matter. And permutations where it does. Rather than saying it, I'm gonna write the word order. Both of these make a certain assumption. These both assume every object or entity involved is unique or distinct. Yeah, some of the fucking meat toppings they put on pizza, I don't know, they're pretty fucking close. But in general, they all have distinct names and they all have distinct flavors. But like permutation, yeah, when I'm choosing the 3 people in class, you all are presumably unique unless you're a twin. And even then, you're unique by, maybe not by genetics, but by what's happened in your life. You all have different experiences. Even twins, and so people are different. So what about when they are non-distinct? We have example. 5 white flags. Let's go, I don't know, pick a low number. 3 red flags. Another low number. 2 blue flags. We got a low number for green flags. 4, let's do 4 green. That's all the white flags look the same, you can't tell one from another. Let's say we wanna arrange them, how many different ways can we arrange these in a row? So I'm gonna draw 14 slots. In a row, and I'm numbering them just so I can make sure I got 14. Let's put our white flags first. I don't have a white pen and it wouldn't show up on white paper, but it did, so we're gonna use black. Let's say I put a white flag here A white flag there, we've got a white flag over in 13, maybe 1 and 7. And there's 5 of them, I need 1 more. So for the white flags. I had 14 spots. And I chose 5. And what we were just doing, that is 14 choose 5. Red flags. We've got 3 of them placed. Where should I place the 3 red flags?
6 and 10.
Alright, so how many options did I have to choose from there? I had 1, 2, 3, 4, 5, 6, 7, 8, 9 spots to choose from. And I chose 3. So I have 9, choose 3. My blue flags. How many spots do I have to choose from? 6, right?
Yeah.
14 minus 5 is 9, 9 minus 3 will get 6. If we count them, we see 6 empty spots. We're choosing 2. I like blue, so we're gonna put it in the front and at the end. Alpha and omega. So this is 6, choose 2. And green flags. I have 4 spots left and 4 flags. 4 to place. It's 4, choose 4. They fill up the remaining slots. Maybe I'll make a little flag on each of these. My green pin doesn't get enough love. Students keep my red pin busy and I like using blue and black. So we saw with throughout all this thing, the counting techniques thing, we multiplied results. So we're gonna have 14 choose 5. We're gonna multiply these, but I'm gonna write these in the format with factorials. So 14 choose 5 was 14 factorial. Anybody remember combination, how the factorial system works? They both have n factorial and n minus r factorial. Does combination have the r factorial also, or is it permutations? What? It has the r factorial too. So we've got. This was 14 choose 5. So 14 is on top, 14 minus 5 is 9. And I got 5 factorial there. My red one, I do 9 factorial there. I got 9 minus 3 is 6. And then r is 3, so 3 factorial there. My blue one, I have 6 factorial on top. 6 minus 2 is 4 factorial, and then 2. And for green, we have 4 factorial on top. That's not green. We have 4 minus 4 is 0 factorial. I told you that shit comes up. And 4 factorial there. Yeah, rather than multiplying all this shit out, cause that'll defeat the purpose of what I'm trying to show you. Let's cancel shit that appears on top and bottom. Before I do, I wanna make sure everyone's got this written down before I start canceling shit though. Damn, 20 minutes into the lecture, you're already yawning, Bell? It's fucking cold.
That's the one in the morning, I usually go to bed at 9.
How do you go to a fucking concert and go to bed at 9?
No, I said I normally do, we didn't get home till like 1 in the morning. So my sleep's all jacked up.
See, grandmas can't stay up that late, don't let grandmas pick you.
No, it was like the second song of the last set. And then my work is like, are you yawning?
But you're like one of the oldest people you were, that's not an age joke, it's just. Well, maybe not, optometrists tend to be, well, I don't know, most days, fucking optometrists.
No,
tend to
one
be
of the
fucking young
ones
bastards.
I work for, she's 27. My daughter's gonna be 26.
Maybe you wanna slap her,
I
like,
know
you're
what
scared, you have your shit together too well. Should be a fucking doctor already at age 27. You haven't lived life enough, alright, what cancels here, that gave everybody time to talk.
9.
The 9 factorials cancel, anything else? 6, 4. What is 0 factorial? 0 factorial is 1, which doesn't affect multiplication. So if I condense this all down, I have 14 factorial on top. Five factorial. 3 factorial. 2 factorial. 4 factorial. Now, this will be a number when we multiply it out, but do those numbers look familiar?
Flags.
It's the number of the flags, right? And the total number of flags. So when you've got a bunch of groups of non-distinct objects. Several groups of distinct objects. Let's say there's k groups. And n is the total number of objects. The number of outcomes. Number of possible outcomes. Is n factorial. Over. Group 1. Factorial. Group 2 factorial. Group 3. Up to group k factorial. Make sense? The rest is calculator work right here. There's no button that does this one. Other than the factorial button, you gotta use the factorial button a lot. So if I were to do that one up above as in a calculator. I would say, this is how I'd enter in a calculator. I would do 14, and then I'd hit my factorial button. And then I would say divided by 5, hit my factorial button. I would say divided by 3, hit my factorial button. Say divided by 2, hit my factorial button. Divided by 4, Hit my factorial button. And then the equal. Cause even though they're all multiplied together on bottom, you are technically dividing the top by each of them.
GPA, is that just for how many groups there is?
Yeah, G is for group and 1 through K is the different number of groups. And like the size is however many flags or what, how many objects is the number that goes in. Does that make sense? Okay. Alright, there's something else in 5.5 that I think we could go over, it's related to chapter 5. We learned the stuff in 5.5, but we really talked about it like before. I don't remember how many students I said, so I'm gonna. Let's just recreate the example, how many students, I think I said I had 22 students in here, let's see. I got 1, 2, 3, I got 7 in that row. 4 is 11, 14, 17, 18 students in here. And let's see, I am going to I am going to pick your gender for you, whether you identify it or not, I'm just gonna count boys and girls, if I'm wrong. I'm not gonna tell you which category you're in, so fine. You're not gonna know if I'm counting or not. Shit, this is harder to count than I thought. We've got 12 women and 6 men. And the question I mentioned before, I think we had different numbers here, but. If I choose 4 students at random. What is the probability? That at least one. Is a woman. Or female. We've chosen 18 to denote woman versus girl, but let's face it. Some females grow up faster, they got a fucking adult responsibility at a younger age. They're adults before they're 18. And some don't have fucking any responsibilities. Or even have like physically mature until in their 20s, so 18 is an arbitrary number. But one woman. Now, we had said with at least one, so with 4 students. I could pick, my options here are 0 women, 1 woman, 2 women, 3 women, or 4 women. Now, you haven't seen the binomial theorem, which shows you how to do 1 woman, 2 women, 3 women, 4 men, women. Trust me when I say, when we get to it, I think it's near the end of chapter 6. The formula is fucking worse than the NCR and NPR. You're not gonna like the formula at all. But at least one. Is that good? And so if we call this event E. Then this one is E complement. And the probability of E equals 1 minus the probability of E complement. We saw that equation before. And what is the probability of E complement? Picking all boys. This is pick all boys. So let's work through the fraction on what happens there. When I pick my first student, how many students do I have total? I have 18, that's the denominator. How many of them are boys at that point? 6. When I get to my second student, how many students remain?
72.
How many boys remain?
5.
It's okay. Your superstar, Kristen, did the same fucking thing. So don't feel bad. We all fucking make mistakes. Even the great Hefe.
Yeah, you can spell that, so. Said, wrote down what's wrong with Kristen.
I want to talk to you. Yeah, that's true. I did. Fair enough. You're right. I did throw shade just about that on Tuesday. Alright, okay, so. Arturo. What about this?
4/16.
Look at that. Let's give Krista a chance for redemption. 3/15. I'm gonna multiply the bottom separately. Let's see what they are. 18 times 17 times 16 times 15. So if I made a fraction, this is 73,440 on bottom. Which means the 1 is the same thing as 73,440 over 73,440. Minus 6 times 5 times 4 times 3. Times 4 times 3. Minus 360. And this generates a decimal.
What's yours?
But this is really close to 10%. 0.1000 to 4 decimal places. Which is about 10%. There's a 10% chance that I will pick 4 women out of 4 picks. Just because there's so many of you, it's normally a lower percentage. How does this relate to what we were just doing? I was picking boys here. Right? Or better yet, yeah, let's do boys. We're doing 1 minus. Not equals. I chose 6, out of 6 boys, I chose 4. I could do 6 choose 4 for the boys. And I did 18 choose 4 for the total. Does that match up? If I do 6, choose 4. Nope, it's permutations. Order does matter because they're distinct people. 6P4 is 360. Which was that number right there. 18P4. Is the 73,440. So you can do the same thing using the permutations shit. I think this makes more sense doing it where you write out the fractions, because then you can stop and think about what's going on. I had 18 students, I chose one of them, now there's one less student and one less boy, and you can write out the fractions like that, and you don't have to stop and go, what formula am I using? You can reason it out. But whichever way you want to do it, you will have problems like this. You will see problems where it says at least 1. Okay? There's also ones where they say at most. But it's doing, you can still separate the grouping. That'll show up. Look at that took fucking a while. I got a question for you guys. I'm gonna have to change it on Zoom just so it doesn't blur. So right now we are on Thursday the 20th, we're doing 5.5. We're gonna get 6.1 down right here. Here's your options. It's important, this is gonna fucking matter, you guys, you're gonna wanna vote on this. We're gonna get 6.1 done today, which means 6.2 is getting pushed to Tuesday. Which means 7.1 is getting pushed to Thursday. Which means you'll have 7.1 and 7.2 on the Thursday, which is right before the midterm. Are you guys okay with adjusting the midterm date?
Yes.
Is anyone against moving the midterm to the following Tuesday? No one? Y'all wanna move it? Okay, we'll move it. So I'm gonna make the midterm on the 11th. I'll adjust the syllabus so it shows up. We have days later on where it just says work on project. Where I am not lecturing at all, you're gonna be working with your teammates. So we're eating up one of those days to make it more reasonable and give you guys more time to do the homework and shit now. Fair? Alright. I will adjust that this weekend. And let's pause right here and give you a break before we start 6.1. There is, we're gonna start chapter 6 now. Chapter 6 is back to Stack Crunch. 6.1. Chapter 6 in general, let's say what chapter 6 in general is about. Chapter 6 is on discrete probability distributions.
This class, do we have to learn about the invisible? Whatever it's called.
I need a little more than the invisible whatever it's called. This isn't religion, so we're not talking about God.
Yeah, just forget it out, because it was in my brain and then it left, so that's how that went.
We're not gonna do the invisible man.
No, it was,
I don't know what part of statistics would ever even have the word invisible in it, so I.
my daughter asked me, and she's like, I hope you don't do that, so then she gave me stress, because I was like, oh shit, you do that? But then-
Well, here it is, like I have no idea where you could even possibly going with it, so no, we're not doing it. Unless you're just completely using the wrong words entirely.
I wouldn't put that past me, I'm pretty sure that she's.
She said invisible. You know what invisible means, right?
Yeah.
What's invisible mean, Beth?
Can't see it,
So how would that ever show up in fucking stats?
I'm asking her right now, so I can redeem myself.
There's no redeeming yourself.
I'm being it.
Did she tell you or the phone not texted you?
We were talking on the phone. I was talking about the exclamation point thing.
That's good that your daughter calls you, that's nice. Alright, so discrete, does anyone remember what discrete meant? What? That's one version of discrete, that is definitely one version of discrete. But that discrete, the secret discrete. Is spelled, has the same letters. But it's like that. Yeah, that's not what we're doing now. So there was two categories, discrete and continuous. Continuous is chapter 7.
Discrete's like whole numbers.
Discrete is whole numbers or countable. But Arturo was paying attention.
My fucking third time taking the shit, so I have to.
Ideally, you do it on the first time, so you don't have to do lap 2 and lap 3. Although you would have missed out on Professor Jones, and this is gonna be an experience for you. Alright, so whole numbers are countable, we're dealing with things we count, not measure. Let's hit you with the formulas you're gonna want right away. Formulas in 6.1. Well, 6.1 is on the discrete random variable in general. We need to talk about what that is. And the formulas you're really gonna want for this is expected value. We usually use E of X. Is the sum of X times P of X. We'll walk through this, some of these, an example by hand. I'll show you how to do a step crunch as well. In fact, let's add the stat crunch commands right now, so it's at the top of your fucking notes. Stat crunch, we're gonna go stats. Calculators. There doesn't seem right. Yeah, custom. It will prompt you for two things, one of them will say values. In that one, you put the X. Which is your outcomes. And the other field it will ask you for is weights, and you will tell it where your P of X values are. So help me God. Fucking, you're an addict. You have issues. I pause for fucking a second, she's looking over to see how many words she can read out of her paragraph. Before I start talking again.
This is the only time that I actually get to read this book, otherwise I'm only listening to it. I'm not going to read it, it's better.
Never tell a teacher the only time you get to read is during this class. That's some fucking insulting shit. God damn. This app is getting more and more discreet. It's gonna be secretive, but it will be there. Alright, so what is a discrete random variable? What's a random variable? Let's start with that, because chapter 7 is on continuous random variables. So we need to lead with what the fuck is a random variable? Slow down on your cussing, David. We talked about this last Thursday. You cuss too much. You don't need to cuss all the time. Random variables are numerical measures of the outcome from, that should be one word, it doesn't look like it though, from a probability experiment. They tend to write it like this. Probability of big X equals like a little x. And this symbol, the equal symbol, can be less than, it can be greater than, it can be less than or equal to, it can be greater than or equal to, or it can be equal. Capital X. Capital letter. What am I gonna call this? The category? The categories of the outcome? And lowercase. Is one, or it's. One of the possible. Numerical outcomes. It can't be something like heart, because heart is not a number. Cause we're gonna have to multiply it by the probability, and heart times probability doesn't make any sense.
Symbol that means imaginary numbers.
I? No, there's no I in here.
No, I'm just saying, that's what she said it was, what she asked me about, a symbol that
Okay.
means imaginary.
We use I for that. Engineers will use J, but no, we're not doing any imaginary shit. This is just an introduction. What stats did she do that has I in it?
Genius. No, seriously, she's so smart. I'm like, where'd you get it from? Your dad's really not that great. But she's like, it's just,
You know, just because we're smart doesn't mean that we're weird.
no, she just. It's smart. Yours is. Huh?
Man, she's all fucking fired today. I know how I can punish her. I'll just stop ordering fucking cupcakes from her. See how quickly she fucking changes it to, Mr. Jones, have I ever told you, you know, what a great teacher you are?
Yeah, but see, I know you love my cookies too much to do that, so.
That's not true. I can buy fucking cupcakes anywhere.
That's really.
Just because I like the cupcakes doesn't mean I have to buy them. That would put me in debt real quick if everything I liked I had to buy. God damn,
Oh, damn cupcakes, huh?
I'm married, I don't need to make my own, I'll get my wife to do it. That is not a sexist comment. I work full time, she's a stay-at-home wife. Okay, I realized as soon as I said it how sexist that sounded. That is not a,
That's a straight to the kitchen comment, all right there.
it sounded like it, it's not. I will make jokes like that, but I rarely do it at school. Just because there's gonna be one day that some woman, or maybe a guy, just goes, this is some fucking sexist bullshit. Completely ignoring the laughter tone in my voice. I did it with my. We were at, it was with my wife, we were at Friends' last Saturday playing, Sunday, we were playing board games. And they were talking about a new appliance. We were talking about the dishwasher. And they were talking about, yeah, their dishwasher had like a remote, or their oven had not the oven. Oven had like a fucking app that you could like do all sorts of shit. And then we started talking about the dishwasher, and then they're like, the dishwasher's great, I'm like, dishwashers are great, I have 2 of them. And my wife just gives me a dirty look. Cause she knows I was making a sexist comment, but it was more of a, my wife acts the jackass just like Krista does. She's over here taunting me, my wife does the same shit. So it's fine, we're happily married after 20 years.
Fun facts I have is. And they torture me, so I don't know how to do it.
Wait, what?
I said, any fun facts I have, and making fun of people is because I have 2 older siblings that did to me.
But I'm not your older sibling,
No, but they taught me how to do it to other people, so now I.
that's usually where it comes from. Yeah, if. I'm perfectly fine taking it, if you can't dish it, or if you can't take it, don't dish it. That's a rule of life. Don't fucking cry if you're fucking throwing the shade first. Alright. Back to an example, I gave everyone a chance. Has anyone in here not played rock, paper, scissors? It's not whether or not you like the fucking game. Presumably, everybody has played rock, paper, scissors. So let's say. Krista and I play 5 games. We will record the number of games. That Krista loses. Yeah, I could have went with you winning, but
Just say yourself winning.
I could, but. Me winning and me saying you lost is there's different, there's a big difference. In rock, paper, scissors, there's a big difference between me winning and you losing. Or me winning and me not winning. Cause we could tie. Which means like, I only win 1 out of 3 scenarios. That's better. Krista doesn't win. No, I wanna go with loses. It's more helpful here. That's our X, that's our big X. Krista's losses. So how many could she lose? Straight to the big one, that's right.
2.
Rather than going and fucking just jumping around, let's just go in descending order till we get down to 0. She could lose them all, she could win them all, or anywhere in between. So. Would it seem intuitive to say that she wins the overall game? Fuck, loses is not good, not for where I was gonna go with this. Fuck, I hate doing this. Let's change it to Krista wins. Fair to say. She wins. If she wins 3 or more individual games. Like best of 5 kind of thing. That seems fair, right? So what Krista wants to see here is the probability that X is greater than or equal to 3. Krista wants this. And David wants this. What am I gonna put here, Krista? What do I want to happen?
X is less than.
X is less than 3 works. I could say X is less than or equal to 2. But in all reality, what David really wants is probability that X equals 0. He wants to crush her. Break her will to ever play rock, paper, scissors with me again. Will be stomp. What are you doing?
You guys actually play.
No,
Just play,
I am talking we're outside of the room.
I thought you guys should.
you guys play 5 games.
Yeah, just to solidify it.
Yeah, just to solidify it, so.
Just to prove your point. In front of the class though.
Oh, they want you to come up here. Sweet, I'll stay at my house, sit in my chair.
Don't keep
So what?
Don't keep track here. So if we go 1, 2, 3, then throw or throw on 3? 1, 2, 3, then throw, okay. 1, 2, 3. Oh, fucking a tie. Oh. Oh shit, this is fucking wrong. Yeah.
Oh, you got it wrong. That was fucking.
So
again.
we have 2 ties, 1 each. 3
What the
ties.
fuck?
So out of 5 games, neither we had, that was fucking odd, right?
That's crazy.
That was crazy.
So, it looks
3
like
ties out of 5 games.
you can't crush Krista, you guys are on equal
Yeah.
par.
You guys are on the same page.
On the same page.
Although I did outsmart her on the 3rd throw.
Technically, you won because you got one more win.
Yeah.
Technically. I'd say.
She assumed I was gonna go for what defeated her last throw. So we both threw rock, then she knew I threw rock, she assumed I was gonna throw paper, so she threw scissors.
I think
This-
for you,
This way with rock, paper, scissors, just don't.
That's not what your thought pattern was?
When
Just randomly thrown?
When you beat me, you went to the guy.
Right, that was the 3rd throw. Cause on the 2nd throw, I threw scissors, you threw scissors. So on the 3rd throw, if I was trying to beat you and beat your old throw, I would have thrown rock, and so that's why you threw paper. And I knew, I had a feeling you were gonna throw paper. Cause you were trying to think like that. And then the last one, after that, I just started throwing random.
Sure.
See,
I really did, there was a
she did
spot
when
where
you just gave up.
Yeah.
Is that what it is? You just gave up?
No, she didn't,
We'll go
you
with
just
that.
gave up.
Alright, so we get the idea of how this kind of works? Okay. This is our random variable, number of wins. The category. And these descriptions, the numbers. Describe the outcomes being looked for. Fucking auto brightening. This is a discrete model. Because X has a countable number of outcomes. In this case, there were 6 outcomes. So that's the discrete part. Or that's the random variable part, that's the discrete part. I said this was discrete probability distributions. So what is a probability distribution? You taken any other college classes before, Krista?
So 1, 2, 3.
So few. It's a shame that you got me so early, it's gonna ruin college for you. You're never gonna have fun with another teacher like me. What is, look at this, what is the probability distributions? Let's try to fix that. Before Chris realizes I fucked up my grammar again. It is a table. Listing all the possible outcomes. And their probability. So I was able to make a table for it. X would be wins. Probability of X would equal a specific number of wins. And we would have 0, 1, 2, 3, 4, and 5. And if there was not the human element of chance, we could calculate this probability. But there is, so these are gonna be like question marks for now. Cause it's up in the air. Although I wanna point out. You all said I lost. But Krista wanted 3 or more wins. David wanted her to have less than 2. She only got 1 win. So David wins. David got what he wanted.
Technically.
David got what he wanted.
Technically, you said that what you actually wanted was for me to win 0. That was what you actually.
But the most. What I wanted the most,
Reality.
but I would accept anything less than or equal to 2. So I got the category of the outcome I wanted. Even though it wasn't the 0, it was close. Oh, it was so fucking close to 0.
It's not that.
That makes it sound like I got a lot of wins and I didn't, but. That's okay.
I thought.
So let's give you an example that has something that we use. And this is from a while ago, I don't know how many years ago, but. This is from when Netflix. Mailed out DVDs. You even remember that?
Yeah, that was used to be the only Netflix we had. We still had it like 3 years ago.
Why are you looking like that? Our chair doesn't know what I'm talking about.
No, I do, I just don't believe that was 2 or 3 years ago.
I don't think it was 2 or 3 years ago.
Yeah, fuck no. That shit was.
That was Redbox.
That was
Redbox.
Redbox shit.
No, we did still have some,
You never give it back?
yeah.
Oh, just because you had them didn't mean they were still doing it, it just means you didn't return them.
You stole it. You stole the fucking-
That's a big difference.
It means you're confessing to a fucking crime.
No, after they had to pay for it.
Nope. You stole that shit.
Netflix bills your ass for DVDs you never returned. Pretty sure they do or did. Alright, anyways, so this is from clearly a while ago. This was number. Actually. It says number of movies streamed, but I know this is it's not mailed out DVDs. Number of movies streamed in a month. It's still. A while ago, because you'll see where the table stops. So X will be our number of movies. And it goes up to from 0 to 5. And the probability of X associated with these. There was a 0.06 chance or 6% chance no movies were streamed. A 58% chance that 1 movie was streamed. A 22% chance 2 movies were streamed. 10% for 3 movies. 3% for 4 movies and 1% for 5 movies. Now, the only homes that stream that few movies of Netflix are the ones that also have fucking HBO and Showtime and Hulu and too many fucking channels to pick from. Like my household. Since my wife is the stay-at-home wife, it's because she was diagnosed with cancer 20 years ago. Brain cancer, so she's disabled. Son is not just to raise kids or anything like that, she stays home for that, but since she's home all the time. I buy all the facts, we got Showtime, we got HBO, we got Stars, we got. So she's got shit that she can watch whatever the fuck she wants, that way, when there's something I wanna watch, she doesn't watch it because there's nothing else left to watch. She got plenty of shit to watch.
Good man.
She takes care of me, I take care of her. That's how it is. Alright, so. Probability distributions. Have to match up. With what we know of the probability rules. But I tried to spell out when I didn't give it a lot of room. Must meet the probability rules. There were two rules. Does anyone remember one of them?
Gotta be greater than one.
It was even more than that. It was, they can't be less than 0 either, but yes. Probability's gotta be less than or equal to 1, it's gotta be greater than or equal to 0. So no negative numbers, and no numbers bigger than 1. 0 and 1 are a valid option. You're more likely to get a 0 than a 1. A 1 is when like there's only one outcome that ever happens. And 0 is an outcome, like 0 probability is like. Yeah, they could rent like, or they could stream like 1,000 maybe, 1,000 reasonable. They could stream 200 in a month. But 0 households do. So you're more likely to get a probability of 0 than a probability of 1. What's the other rule? If I add up all the possible outcomes, what percent should I get? I should get 100% if I add up all the possible outcomes. What is that in terms of a number? 1. The sum of P of X has to equal 1. Sigma means sum. We mentioned that before when we talked about standard deviation. I showed you the formula that they use that we didn't use. That was being merciful and saving from that horrible math. I don't wanna go grab some imaginary numbers.
Stop.
I think I could do it in 6.3. No. Yeah, 6.3's got e to the x. You know, this is just, she's already texting her daughter, she's fucking threatening it now.
You see what you?
Do I meet the criteria with my table here? Those are the 2 rules, did I meet them? Rule A and rule B. Hopefully, rule A you can figure out really fucking quickly. Are any of these probabilities negative?
No.
Are any of them greater than 1? What about the last one? What? Add them up,
8 to 1.
do they?
Yeah.
Did you do it? Or are you just making an assumption? To tie this back into histograms. What? We did histograms a while ago. Go with that's 50% and 25%. So 0.06 is right about there. 58% is above the bar. 0.58. 22% is almost up to the 25% line. 10% is a little above 0.06. 0.03 is even shorter than the 0.06. 0.01 is just a fucking smidgen. I'm approximating the heights of them because I don't have a grid and I didn't wanna waste all your time drawing a grid, but just a reminder of how you might see these things, they show up as histogram. People are still writing, that's why I'm waiting. So Clint Black and then rockabilly, what are we gonna do next, like heavy metal, death metal?
Next, on March, we're gonna go see, Weird. That's like old school punk.
But queers, I don't recognize the name, what are they saying? You listen to any group that has, Clint Black is famous, no mind.
Reverend Martin is famous.
Sure he is. Anybody heard of Reverend Horton Heat? Anybody?
Okay.
Bueller?
Half my age.
I'm your fucking age. I don't know who Reverend Horton Heat is.
They're rockabilly.
We already established that. I really wanna go see the Stones. But the Stones, the tickets for the fucking Stones, even like the nosebleed are like 3 digits and not like low 3 digits.
That's how it is to go see
How it is to go see what?
Chris Stapleton.
Yeah, those shits are. Randomly, I searched those up a long time ago, they're fucking high.
Alright, let's do expected value. That's what we're covering in this section. Expected value is E of X. We also call it mu of X. Because it acts as our version of the mean. Mean value. And this was the sum of X times P of X. So I'm gonna remake that table because I foolishly drew the histogram right next to it, so I couldn't do it there. But it's a quick throwdown of the numbers. And in the next column, I'm gonna do X times P of X. Is 0 times 0.06. What about 1 times 0.58? Zero point five eight, anything times 1 is itself. 0.22, if I multiply by 2, I can double each number, I get 0.44. 0.10 is like a dime, if I've got 3 dimes, I have 30 cents. 4 times 3 is 12, so 0.12. And 0.05. 5 times 0.01. So I did this times that equals that. Let's see, I got 8 and 4 is 12, plus 4 is 14, plus 5 is 9, carry a 1. 10, 14, carry another one, 1.49. Mu of x, or the expected value of x, is 1.49. So this is one way of finding the mean. We find the mean. This way, because. We don't have. Every house's response. We have summarized data. I don't even know how many homes there were, and I could, if I knew how many homes said them, I could still calculate it the old fashioned way. If we actually have the results. If we have individual house entries. It didn't mean the old fashioned way. And what I mean by the old fashioned way or the regular way is for our class. Our class, we would do stats. Summary stats. Columns like we did in chapter 3. But since we have the data is already summarized, we're not trying to summarize the data. We have to do stats calculators custom. So we'll go do that now with these numbers and show you. Staff, I'm ready while you guys are writing. You guys ready? Was it a uh-huh? Okay. Can't possibly be enjoying that book fucking 3 sentences at a time. There's no fucking possible way that's good. She can only do it because she's read this fucking book before. I fucking double dog dare you to do this when the Wind and Truth when you get to it. I wanna see you read it fucking in between when David's talking.
And I will be that time.
You got a whole page that time? Yeah, there was a longer wait. Some of them. You don't get that longer wait. Alright, everyone good now? Okay. Alright, so here's my stack rank or my. Math lab, click on the stack wrench one. Open stack wrench. We need to have a column for X and P of X, so I'm gonna do that. But I'll call it maybe movies. And P of movies. And we had 0, 1, 2, 3, 4, 5. And this was 0.0, so let's see if I can remember them. 0.03 and 0.01. Alright, so once you have. Wow, it's fucking glitching because it doesn't hold up both like there, okay. So stats, calculators. Normally shows more than that, so zoom out a little bit. Stats, calculators. Notice that everything on calculator is alphabetical except custom. If you're looking for shit on these things, they're almost always alphabetical. Except custom is bugging since it does its own thing, we're doing that. Now we said values are where our X values are, so that's where my movies are. And weights are in probability or P of movies. And it tells me what that mean is right there. That's the 1.49 we calculated by hand. Are you recording this? You know I record this already, right?
But if I just need help with this part.
Okay,
I
that's
forget-
fine.
I forget everything.
So check this out, like if this was like the number of games Krista won. Krista wanted X to be greater than or equal to 3. And I can change that to that. And it's giving me 0.14. How do you think it's getting 0.14? It might help if I show a different one. Let's see if I show less than or equal to 1. .64. Can you all see the red lines versus the black lines? The red lines are highlighting what lines are being counted. So it's counting the line for 0 and 1, 0.06 plus 0.58 gets you 0.64. You also have an option for going like between values. I could say I want between 1 and 4. What numbers do you think this is going to choose? It already shows. It shows the less than or equal to. It's going to show all of them. Here you have to definitely make sure you're paying attention that it's going to include your endpoints 1 and 4. On standard, I said I wanted one of two things. Well, I wanted X equals 0, but I said X is less than or equal to 2 works. Or I could, and notice 0, 1, and 2 are highlighted. Or I could say X is less than 3. And I also get 0.86, which is 0, 1, and 2 highlighted. So on this standard, the regular one, you gotta pay attention to the symbol. Make sure you can see the numbers that it's including by the red. Make sure it's including the ones you think. Okay? Anybody ever heard of roulette besides Val? Only one of you. That's good. You know roulette, Val, right? Alright, let's show a roulette table real quick. Let's do the layout. They got the single zero and the double zero. Let's go with the classic. Whoa, that's not what I want. Pick a better image. Oh, that's even better. So there's a wheel. The wheel spins and it perpetually spins. It's on an engine. It's got a motor attached to it. It's constantly spinning. They flick a marble the opposite direction. The marble circles around and eventually friction causes it to slow down and it falls down and drops into the bottom. It's at a, there's an incline. It's like a tilt-a-wheel, but very like shallow. And it falls into a bucket. On the classic table, there is one to 36 numbers and then a number for zero and a number for double zero. So a total of 38 choices. What?
Just make me wanna go to the casino. Like, look
Well,
at
maybe you won't when I'm done with this. So there's a variety of ways you can bet. You can bet on all even numbers or all odd numbers. That does not coincide with black and red. They deliberately break it up. Red, there's like half the even numbers are red, half the even numbers are odd, half the black numbers are odd, half the black numbers are even. So you can bet on red or black. You can bet on the first half versus the second half of numbers. You can bet on 1 through 12. You can bet on a single number by putting your chips just on that number. You can bet on two numbers by putting your chips, they have to be like touching each other. But I can bet on 1 and 2 if I put my chips on the line between 1 and 2. You can bet on four numbers. If you put it in the corner like here, I could get 1, 2, 4, and 5. Here, there is a way to get three numbers, but it only involves using zero and double zero. I can bet on 0, 1, or 2 right here. They have each different thing as a particular payout. I can bet on a column or a row here. There's a 2-to-1 payout for these. There's a 2-to-1 payout for each of the 12s. Even and odd, black and red, and first 18, last 18 are all 1-to-1. So what happens in terms of gambling? Let me go back to the picture real quick. Share. So most tables have that 0 and double zero. Most tables have 0 and double zero because it's more favorable for the house. And then the number is 1 to 36. That makes a total of how many numbers? What? 38. The 2 zeros and 1 through 36, that adds up to 38. So if you bet on a single number. The payout is 35-1. About to say, make sure everybody's done ready. If you bet $1 and hit. You win $35. That's how all the payouts in casinos are listed on a table. It will say a number to a number. Usually it's a number to 1. Every once in a while, you'll see something like 3 to 2. Like sometimes blackjack tables have You hit a natural blackjack, they'll pay double or they'll pay 3 to 2. Which means you get 50% more kind of thing. So let's make a probability table, what's your favorite number, Val? Pick a number between 1 and 36, what?
13.
Excellent choice.
Thank you.
So probability that 13 is rolled. Okay, so what we're gonna do is our category. X is. Let's see, how do I wanna say this? I don't wanna use the number, cause that's not what we really care about, we care, cause the ball number doesn't matter. What we care about is what we win, right? So X is gonna be the amount 1. That seem fair? That's what we care about when you're gambling. Whether you gamble a roll on a 7 or a 13 or a 25 or 00. So if I do X and P of X here. If I win $35. If I lose, how much have I won? Well, I've technically lost $1. So we're gonna go -$1. If you win, you also keep the dollar you bet. That's important to note. You don't lose it either way. It matters, cause like the next example I'm gonna go over real quickly will be life insurance, and that does matter. The probability of winning, there is only one 13 out of 38 numbers, it's 1 out of 38. This is about 0.0263. Every other number on the grid is not 13. So there are 37 ways to lose this bet. This is 0.9737. And these are the only 2 outcomes Val cares about, she's only betting on 13. Notice that the probability. The sum of the probability adds to 1, and they're all between 0 and 1. This is a valid distribution. If I do X times P of X. I have $35 times that 0.0263. This equals 0.92. And this one, -1 times 9737. I'm going to 2 decimal places because money goes to 2 decimal places. I have -0.97. So when I add these up, my expected value, that's not expected. Expected value or mu of X. Is -0.05. A nickel. Is there any way she can lose just a nickel here? Or anybody? No, you can't lose a nickel. This is over the long run. Over the long run. Every dollar gambled. On a roulette table. Will cost you a nickel. You might have short-term wins, but if you play a lot, in the long run, you're down. That doesn't seem like a lot for a casino, right? A nickel? I got a fucking big old building around with electricity on and fucking employees to pay and. But who bets $1? Well, poor people will bet $1, but most people go to the casino and they're betting like $5 chips. They're not just betting on $1 on one number. The people that play roulette tables, they're fucking all over the place. They're betting money everywhere. If they see, I don't know, if they see $20 million in a month. On a roulette table. $20 million times that 5 cents lost in terms of for them is 5 cents won. That's a profit of $1 million. You're losing a nickel at a time. It doesn't show up. You're either losing $1 or winning $35. But in the long run, if you average it out, you're losing about a nickel every time. Any house game where you're against the house always has a positive expected value and you have a negative expected value. Interestingly enough, no matter which choice you choose on roulette, you chose odd or even, black or red, columns, anything like that, it boils down, the expected value is a minus a nickel every single time. The odds are set up perfectly, so it's down a nickel. There is another variation in the roulette table that has a single zero rather than 2 zeros, and the house's edge drops from 5 cents down to like 2.7 cents. They generally don't offer it in the regular room, it's the high roller room. You gotta be playing hundreds of dollars for them to let you play on that table, because they're making less money on each one. And they wanna make it worth a while, so they're expecting to see thousands of dollars going that motherfucker. I will talk about the life insurance one on, there's another one that goes along with this. Term life insurance, will cover it on Tuesday, along with 6.2 and 6.3.
You'll be there Saturday, right?
And I will be there Saturday, but you probably won't.
Huh?
Have you come yet?
I know I'm going to.
Or you don't? Okay.
I go back to, I get my son on the weekend, but I'm not gonna go back to the week. If I can. He's 13.